Okay, have you ever really stopped to think about how the massive amount of electricity from a power plant gets safely to your home or office? It's not magic, that's for sure. It's all thanks to this hidden world of control boxes, circuit breakers, and switches. So today, let's pull back the curtain on the master control system of our electrical world, switchgear.
Now, in this world, there are two main players: high voltage systems and low voltage systems. They might sound kind of similar, but trust me, they operate in completely different leagues. So, what's the real difference? And, more importantly, why does this distinction matter so much for everything from a giant factory down to the lights in your room? We're going to break it all down.
First things first, what even is switchgear? Well, the best way to think about it is as the beating heart of any power system. It's not just one single thing. It's a whole collection of components, all working together to do three absolutely crucial jobs: to control the flow of electricity, to protect the whole system from dangerous faults, and to isolate equipment so it can be safely worked on. Without it, our electrical grid would just be pure chaos. All right, let's start with the big guns. We're talking high voltage, or HV, switchgear. This is the stuff that deals with any system pushing more than 1,000 volts. This is the heavy-duty equipment responsible for wrangling colossal amounts of power across huge facilities and entire distribution networks. So if you were to crack open an HV panel, you'd see that every single component has a critical job. You've got your protection gear, like massive circuit breakers. You've got the connection hardware, like bus bars, that actually move all that power around. And then you have your control switches, your measurement transformers to keep an eye on things, and of course, isolation switches to safely shut it all down for maintenance.
But the real star of the show in an HV system is the power circuit breaker. Now, this is not like the little breaker in your home's fuse box. This thing is the ultimate safeguard. It's engineered not just for the daily task of turning circuits on and off, but more importantly, to instantly and safely stop a catastrophic current during a fault, literally saving the entire network from blowing itself up. And to do that, they use some pretty cool tech. Some use a vacuum, others use special gases or even oil to extinguish the incredibly dangerous electrical arc we're about to talk about.
So how does all that insane amount of power get distributed inside the panel? It's all thanks to bus bars. The best way to picture these are as the electrical superhighways of the switchgear. They're these thick copper or aluminum bars that efficiently channel immense currents from one main source out to all the different circuits.
So here's a question: how do you measure thousands of volts and amps without, completely vaporizing your instruments? Well, the simple answer is you don't do it directly. Instead, HV systems use these brilliant devices called current transformers and voltage transformers. Think of them like a gearbox for electricity. They step down the current and the voltage to safe, tiny, measurable levels that all the meters and protective relays can easily read. It's pretty genius, actually.
But with all this high voltage comes an immense danger. And the source material puts it bluntly: the number one cause of an explosion in HV switchgear is something called an electrical arc. So what exactly is an electrical arc? It's basically electricity deciding to jump through the air, and when it does, it creates a massive explosive blast of energy. The heat is so ridiculously intense, it can vaporize metal on the spot and cause catastrophic, often irreversible damage to both people and equipment. And this is precisely why those HV circuit breakers we talked about are so complex. Their main job is to contain and extinguish these violent arcs before they cause a disaster. Okay, let's shift gears now and move to the other side of the power world: low voltage systems. If HV systems are the heavy hitters, then LV systems are the everyday workhorses. They operate at voltages up to 1,000 volts. This is the kind of switchgear you'll find running factories, commercial buildings, and yep, even our own homes. The components in here are probably going to look a bit more familiar to you. You've got simple fuses, which just melt to stop an overload. Then you have their modern, resettable cousin, the miniature circuit breaker, or MCB. You'll also find contactors for automation, specialized breakers just for protecting motors, and a whole host of relays and timers that provide all the control logic. Let's zoom in on that contactor for a second. This little device is a huge player in low-voltage automation. It's an electrically controlled switch, and it's designed to be turned on and off over and over and over again, sometimes thousands of times a day. It's what lets a simple, tiny signal from a control system start up a massive industrial motor. Pretty cool. See, low-voltage systems are really all about precision protection. They use specialized little gadgets for very specific jobs. For instance, a bimetal relay will protect a motor from slowly overheating, while a phase monitoring relay protects it from damaging voltage problems.
It's all about making sure that expensive equipment lasts as long as it possibly can.
And this slide really gets at the custom-built nature of LV systems. Designing one is a pretty straightforward step-by-step process. First, you figure out exactly what you need it to do. Then, you draw up a schematic, laying out all the specific components. And finally, you calculate the cost. It's highly tailored to the exact job it needs to do.
Okay, so we've met the heavy hitters and the everyday workhorses. Now let's put them side by side and really nail down the key differences once and for all.
And this is where it all comes together beautifully. Putting them head-to-head makes the distinctions crystal clear. Voltage, that's the obvious one. Are we above or below 1,000 volts? But check out safety. HV is all about taming those explosive arcs with really complex methods. LV is more focused on simple overload protection, and that difference directly drives the cost. HV gear is way more expensive because it has to be so robust. LV is more affordable with simpler parts. And finally, application. HV is for distributing bulk power, while LV is all about the final control and protection of individual pieces of equipment.
So after all of that, why is it so incredibly important to get this right? Well, because picking the correct switchgear isn't just some minor technical detail.
So what are the crucial takeaways here? Let's boil it down. Number 1, voltage is the clear dividing line. Are we above or below 1,000 volts? Simple. Number 2, safety. The main concern shifts from managing explosive arcs in HV to preventing equipment burnout in LV. 3, cost. It's a direct reflection of that complexity and the raw power being handled. And finally, number 4, application. Are you distributing massive amounts of power or are you controlling one specific machine? Because ultimately, this decision affects the entire system. Getting it right prevents catastrophic failures, it protects human lives, and it gives us efficient, reliable power. But getting it wrong, that can lead to destroyed equipment, expensive downtime, and most importantly, it can be a serious safety hazard. It's truly one of the most foundational decisions in all of electrical engineering. And that leaves us with one last thought. As electricity makes its incredible journey from the power plant all the way to the wall outlet right next to you, it passes through both types of these systems. So the next time you flip a switch, just take a second to think about that amazing journey and ask yourself, which one of these unseen, unsung heroes is working for me right now?